All right, what about rotating a region between two curves? Can you work out how we're going to do that? It's really just a simple application of what we've learnt so far. Here's my curve, and rotate it around the x-axis. I'm going to get, it's kind of an annular solid. It's a ring with a hole in the middle. How am I going to work out the volume of this shape? And if I'm rotating the same two curves around the y-axis, I'm going to get something like this. Again, what's the volume of this shape? How am I going to work that out? Well, let's try it. Now you do have to be careful. You cannot simply subtract this function from this function. That doesn't work because then as you rotate it in the larger shape, you're going to end up with this one goes around further than this one. Hold on, let me show you in the diagram. So as I rotate it, the circumference on the outside circle is bigger than the circumference on the inside circle. So you can't simply subtract the two functions and then integrate. But what you can do is work out the volume bounded by the outside and subtract the volume bounded by the inside. Basically, it works if you get the squares of the two functions. So, my two functions are square root of x and half x. Well, I'm going to get the integral of pi y squared dx minus the integral of pi other y squared dx. And each of these we can then simplify. So, put those two together into one definite integral because we've got the same bounds, we've just got two functions squared. This is what I'm saying. You can't just subtract root x minus half x, but once you've squared them, you're okay. Okay, something squared minus something squared, integrate. This one is just x. This one is a quarter x squared. You can integrate each of those, put in your values and subtract. Some of them turn out to be very easy because you're multiplying by 0, and here's your answer. Interpret that as a volume. 4/3 pi was the volume of the solid generated between those two. Now, your textbook gives you an important warning you need to pay attention to. This you can write as one integral like this, but what you cannot do is then take that and write it as 1 squared. Remember, this all squared is not the same as each piece squared. Okay, so be very careful with that.